So we need to create an environment for creativity. So what do we do about it? How do we get that? How do we get those creative juices flowing? Um, Freedom to criticize status quo and authority. The 80-20 rule, that you work 80% of the time on what the authorities tell you, 20% of the time working on your own ideas. Creative people don't fit in traditional organizations. Back in the 80s, 70s, late 70s, early 80s, IBM executives said, you know what, if we develop a PC here at the Thomas J. Watson Research Center, we're not going to get anywhere. We're not going to be able to compete against Apple. So what we're going to do is we're going to get really bright people. We're going to send them far away from company headquarters, Boca Raton, Florida, and their job is to make a personal computer. The IBM PC was born out of that. Top executives got them out of the culture of the traditional organization, is what they did. Explore opposites. We discussed that earlier. Break the stereotypes. When you're defining your problem formulation, when you're coming up with the functional requirements, make them good and broad. Other person's point of view. The Wilbur and Orville Wright story was interesting. Of course, they invented the airplane back in, when did the first airplane fly? 1907? Or 1903, excuse me. But Wilbur, for example, would argue over a design feature, like canard versus tail. Modern airplanes have tails, that you have the rudder behind the wings. Ducks, birds, some birds, they have their rudders in front of the wings. Their head is the rudder, literally, of their flight, of their airframe. Birds do that, and some aircraft do that. Anyway, and the Wright Flyer had a canard, by the way, that the elevators and the rudder were in front of the wings. Instead of today, they're behind, which is what we traditionally think of. But Wilbur would argue, say, for a tail for 15 minutes, and Orville would be the devil's advocate against the tail. And then Orville would argue for the tail, and Wilbur would argue for the canard. They switched roles, which is a perfect way to get to see things from another person's point of view. And these techniques that we are talking about in these slides, do them and report them in your notebook. Okay. Intentional breakthrough. So there's blocks. Fear of ridicule. That's why we use brainstorming. It's anonymous. You put down an unconventional idea and you throw it into the brainstorming pile. And nobody knows who wrote it down. There might be peer pressure. When you're new, it's hard because you're not used to the the older folks. They have their way of doing things, and you think, oh, maybe maybe there's something I don't know. You're afraid to expose yourself because then you might be ridiculed. Cultural reasons that a lot of times managers say, well, can you prove this? No, I have a good idea. If it works out, I have a gut feeling that it'll work. If it works, it'll be revolutionary. So let's try it out. So a lot of times companies want a solution that works over a promising idea. Well, we just don't have the time right now for that. Okay, What are you going to do? So you got to make room for those promising ideas. By the way, this addresses it a little bit. You get to spend about 1/5 of your time on promising ideas. Some companies do this. Okay, intellectual, which means maybe there's some knowledge your team doesn't have. This is a great one, the silhouette of birds. So engineers had the problem of keeping birds from flying into windows of buildings. And they came up with deflectors and shapes and different wind designs and things like that. And what a biologist said is post silhouettes of predator birds around. And that will keep the smaller birds from flying into the windows. And it worked. It worked fabulously to scare other birds away from buildings, is these silhouettes of predators. There are communication barriers, expressive blocks, communication barriers. Electrical engineers use different terms than mechanical engineers. They don't understand each other. Premature judgment. That's we like to, well, I can solve this, and you have an idea and you say, oh, let's go do this. And no. Let's consider other options first and decide on the option we're going to go with. Oh, mine's a great option. You hear that all the time. People say, look, let's just take our time and go through the ideas and make a decision matrix, and we'll, as a team, we'll decide on what the best way to approach it is. Maybe you're right. Maybe your idea is a fantastic idea, but let's go through the decision-making process. Let's brainstorm. Let's filter. Let's fishbone. Let's decision matrix and figure things out. Creativity is a process. So the idea that you have preparation, incubation, illumination, verification, that this is your schooling, this is your background, this is your knowledge, this is your research you do on a problem, your studies after you get out of school, and so forth, what you're filling your brain with. You're preparing the soil for the germ of an idea, of something really revolutionary and creative. That's what you're doing here, the preparation. Good functional requirements. Broad, so that you have a big design space. That if you come up with something really radical and innovative, that it'll work. Integrated circuits, that's another good example. What happened was, there was this engineer at Texas Instruments, and he was a junior engineer. He didn't have any time off. 2 weeks over the summer, everybody would go on holiday. And he didn't have the vacation time yet, so he had to stick around the plant. And during those 2 weeks where he didn't have anything to do, he made an integrated circuit. Showed how you could connect up transistors right on the silicon. So, and when everybody else came back, he showed it to them, and the microelectronics revolution was off and running. Let's see, when was that? 57, something like that. Incubation. So rest period, do something. Archimedes is a great example of that. The king thought that the goldsmith was cheating him, that they were mixing silver with the gold. And so the king gave Archimedes the same weight in gold and the same weight in silver, and said, as the crown that the goldsmith made, and said, I think he cheated me, but I need to prove it. And Archimedes pondered the problem and pondered the problem. How am I going to show that this is gold mixed with silver. So Archimedes needed a break. And back in 200 BC, they didn't have indoor plumbing. So if you wanted to take a bath, you went to the public baths and you paid your money, and they would pour in hot water into the tub, just like the Old West, frankly. They'd heat up water over a fire, they'd pour it into the tub, and he'd get his soap and he'd start scrubbing up. And the tub was filled to the brim, and as Archimedes got in, the water started flowing out, and he realized that the volume of water coming out is going to be whatever volume he has. So he had a way to measure the volume. And he took that idea that you're going to displace X amount of water, a volume of water, and came up with ideas of pressure and Archimedes' principle, which is a rudimentary integral calculus. He invented calculus right around 200 BC. And came up with Archimedes' principle, figured out the goldsmith did cheat the king, and the goldsmith wasn't very good at marketing, because the goldsmith could have said, hey, look, this gold mixed with silver is so incredibly bright. It is the brightest, shiniest crown anybody could have. Pure gold is not as bright as my magical, and he didn't even have to say it was pure gold. He could say my magical recipe. It's basically 18 karat gold. 24 karat is pure gold. So the goldsmith should have been a little creative about his marketing rather than just trying to steal some gold. Okay, incubation. That's Archimedes getting in the bathtub. It overflows. He has his aha moment, the illumination moment. He runs through the streets naked and shouting, Eureka, Eureka. And then verification. Let's go. He worked on it afterwards. After he got out of the bathtub, he went home and he wrote down ideas and developed Archimedes' principle and did all the verification work and proved the crown wasn't pure gold. Okay, going to go to the next video. We're going to pick up on brainstorming rules in the next video.